So the next speaker is the second ticket of this session for Bart.
I'm sorry, you don't have to introduce me again.
So we earn a few seconds. Okay, so please.
Yeah, it's not my choice that I come here. Again, this presentation was supposed to be given by Jay Witherspoon. He is also restricted to travel from the US. And as former chair of this IWA committee, he sends his regards and he wishes he could be here. Because I work for the same company, he made me do this. So my apologies for being again here. This study is that has Jacobs undertaken for the Bay Area Air Quality Management District. And in California, an odor attribution study to identify compounds that may be impacting the local community of 3 very close related facilities. And one of them I actually just discussed previous. I'd like to acknowledge the co-authors, Jerry Buffet, Scott Cowden, and also Professor Saffet. Now, this study is in an area where there are 3 very large facilities. And facility A, I just already mentioned. It's the dry anaerobic digestion facility, the largest in its kind in the world. The second is a waste recycling facility. It's actually a landfill, and that landfill receives between 500 and 600 garbage trucks per day. It also has a waste recycling facility where they manually screen out plastics, paper, glass, etc. And it has a composting facility. The third one is, not the least, a large wastewater facility. They're all individual facilities owned by private companies and operated by them. The odor has been an issue in this area for decades. Over the years, various odor mitigation approaches have been undertaken with various degrees of success. While the number of odor complaints from the residents has decreased from a peak in 2015, a yearly of 3,500. For those who were noting off, 3,500 per year, that's about 10 per day, official complaints. It's now a number around 1,500 per year. And so this indicates a persistent and ongoing odor issue. On top of that, the facilities are very closely related to each other. Facility A here has streams like the percolate goes to the treatment plant, the leachate from the landfill goes to the treatment plant, stabilized biosolids from the treatment plant are used for bio cover over the landfill, etc., etc. So there are they are quite independent also of each other. And there are some background odors as well. A large lift station brings the water to the treatment plant, and it's in the South San Francisco Bay where you have the tidal effect that also causes some background odors. The objective here was really to determine the contribution of odor-causing compounds from these facilities. And really, the objective here was to develop a strategy for online monitoring. Now, I can't explain everything what we've done in 10 minutes, but I like to share with you the methodology that we used to obtain an understanding of this relatively contribution of these odors of these 3 facilities that are very close located to each other and how they impact the community. I mentioned already something in the previous presentation. The methodology that we used is a combination of Yes, taking back samples, bring it to an odor lab, have it analyzed on the odor concentration. This was sent to St. Croix. They did also some characterization. We did different groups of odors sampled either by bag or by sorbent tubes, analyzed by specific methods developed for odorants. We did some continuous measurements with H2S, and we used the OPM method, which I just explained in the previous presentation. On top of that, we took back samples and sent that to a lab for a chemical compound analysis, the proton transfer reaction, and this is really to identify or to make a chemical fingerprint. Not so much to identify all the odorous compounds, but just make a fingerprint of the sources. Later, when that fingerprint of the individual sources were made, the mobile lab with the PTR went into community, driving around for about 1.5 weeks, taking samples and do analysis to see if they can identify the different sources using multiple variance analysis. And last but not least, an extensive field assessment was done using a field olfactometer. We trained local staff of the city that was most impacted using field olfactometers, the SM100 of Centroid, and that has been taken over about 1.5 years. They went into the community every 2 to 3 weeks, at different times, different days of the week, and measured the D over T. In addition, they characterized the odors and did some other characterization, which I just will mention later. These are some of the instrumentation we've used. I'm sure you know what that means. To share a flavor of the results that we obtained from the chemical analysis of the different sources, we developed the odor activity values. The odor activity value is defined as the measured concentration divided by its threshold. And so that gives an idea, it identifies how important it is. And here we see the different facilities, facility A with the key sources, facility B, facility C. And here on this y-axis, it shows the dilutions that are then necessary in order to bring it back to the threshold value. And as you can see, in some cases, 100,000 or even over 1 million dilutions are required to get rid of that odor. So really, really high. That helped us also to identify the key sources of these facilities. They're basically in line of order. As I mentioned, we had trained field assessors that went in the community every 2 to 3 weeks over 1.5 years, and not only measured the D over T with the field olfactometer, but also give a qualification of the intensity using this scale here from 0 to 6. And as you can see, this facility, which I just mentioned earlier, is on average 5.7, very extremely strong. Sometimes maximum of 6. The other facilities in generally a bit lower, but also occasionally extremely strong. They also quantified the hedonic tone according to this scale from pleasant, +1, to -3. And you can see here extremely unpleasant. The others a bit less, but occasionally also very, very strong. So yes, this is an odor problem, but we really wanted to know which one is most impacting the community, and if we want to develop some monitoring, where do we have to focus on? So they made also descriptors, and although it all is waste, a lot of organic waste, we were pleasantly surprised to see that they are quite distinguished, and that is shown here in this graphic. Facility A here has been described in most of the time with these 4 descriptors. And these descriptors come out of an odor wheel. You may be familiar with that as a tool, as a guide. These descriptors have been used either with the other facilities or in the community. There were different locations in the community, dependent on the history of odor complaints, where they also went in and did a similar qualification. Now, this has hardly been used to qualify these facilities, and similarly, it's quite interesting that they are distinguishable. And so that was very nice. And based on the information from these field of assessors, and in total there were about 600 observations, we created this high-level visual representation of the likely origin of odors observed in the community. The size of the circle is based on the intensity. The colors is where it is described similarly to one of these 3 facilities. Facility A is here, the green one. Facility B is here, the brown one, red one, I'm colorblind, sorry, and the blue one is here in the middle. As you can see, facility A is relatively close by, very strong. Facility B is mostly here in this area, but reaches further, and facility C, in this case the treatment plant, not so much close by, but further away, there are clearly indicators. So this comes from observation using your nose. This has been kind of confirmed by the OPM method, where the different facilities, as I mentioned earlier, you take a sample and dilute it and see what the character is changing, and how that is impacting actually in the community. This is data obtained from the PTR time of flight MS analysis. These are some examples of the key sources of the main compounds. Here on the axis you see the M to Z value, which is closely related to the mass of the chemical compound, and here we see the relative contribution. Now, we are not after the absolute concentration, but more the relation between the ratios between these compounds. These can then be used to as a chemical fingerprint. As I mentioned, they went in with this machine in the community, took samples, and did statistical analysis. And we were able to confirm. We're still in the process of processing this, but we clearly could distinguish at that time, at that moment, at that location, where the odors mostly come from. Very, very powerful tool that complement actually the observation using the nose. So as conclusion, an improved understanding of the relative contribution of odor-causing compounds from these closely located odor sources has been obtained, and how they impact the community. And this combination of lab olfactometric analysis with field and lab odor compound analysis, surveys using the PTR and the field assessments really helped to get the full picture. That is often not very which is often very difficult, and especially with these facilities so close together. Now, the next steps is really to develop and propose a methodology or a combination of methodologies to employ ongoing monitoring. This would help to inform future actions to reduce odors, to establish methods to measure progress of the facilities. It's clearly that they need to do more. And to also educate the community. They have concerns, but they can also be a valuable tool, as we've seen in some of these presentations. And so by educating them how to identify odors, what it means, they could also play a role in bringing this to a less of a problem in this area. So with that, thank you very much, and open for some questions. Thank you.
Thank you very much, Bart. Unfortunately, we don't have time for questions, no? Maybe just one very quick question. Well, Cynthia allows me, so yeah. If there is one question, Carlos?
If anyone has a question, just say it. The other activity value is a really powerful tool. I like more the relative other activity value more than the other activity value, because I think you have to relate those other activity values to the global contribution of all the chemical compounds that are part of your matrix. But it's good anyway. And as a suggestion that I would like to make to Jay or Mel for the next time is we've seen other activity values, which is a measurement of which is a relationship between the odor detection of a compound and the chemical concentration of that compound. But actually, it would be nice, and I see Mel has the tools to do that. It would be actually very nice to calculate or to find out which are the intensity activity values or hedonic tone activity values, which they would be the concentration of those compounds in order to have a intensity of strong smell or a hedonic tone of unpleasant smell. This would be a good tool also to be complementary with the profile method that Mel uses a lot in order to calculate the overall odor impact of the three facilities. I think it's just a suggestion, it's not a question actually.
Well, basically, I think I know what you mean, but basically that OPM method where you take the bag and you dilute it over time and look at not only the character, how that changes, but also the intensity is kind of what you mean, right?
Yeah.
Okay, cool.
So for those research groups that you work on this kind of stuff, it would be wonderful. Instead of using other activity value, use hedonic tone activity values or intensity activity values and do a relative calculation.
And I would suggest the intensity. And basically, I showed three graphics of three sources just to illustrate, but basically it's been done for all the sources and also different times of the year. So this has been a huge effort, 2-year program. It's still not finished, but yeah, there's much more data to share, and we are happy to show you more. Thank you.
Thank you.